Hey everyone, welcome back to another explainer. Today, we are stepping into the incredibly high-stakes, wonderfully complex, and honestly, surprisingly petty world of arometry. That's the official scientific term for the measurement of mountains. Now, you might think measuring a massive, immovable pile of rocks is pretty straightforward in the age of satellites and lasers, right? But as we're about to see, the science is anything but settled. In fact, a tiny mathematical correction is currently invalidating the grueling weekend hobbies of thousands of people. Let's get into it.
Let's kick things off with a story I think a lot of us can relate to. Meet Christine. She's a staff member at HAI Enterprises, and like a lot of incredibly motivated hikers out there, she has what's been perfectly described as a neurodivergent pleasure for walking up steep, exhausting rocks. Her ultimate goal? To summit all 58 of Colorado's famous 14ers, and she was doing great. She literally poured her blood, sweat, and tears into this, completely confident that she had successfully conquered 48 out of those 58 mountain peaks. Until, well, science intervened.
Now, what I absolutely love about this whole situation is the exact phrase the researchers used when they upended the topographical maps of Colorado. They looked at Christine's hard-earned checklist and officially declared it mega busted. Yeah, she had summited the completely wrong peak entirely.
Ouch. So let's look at Section 1, the hiker's dilemma, and why summits don't actually count.
To officially bag a Colorado 14er, you've got to hit two main criteria. The first rule is super obvious. The mountain must hit 14,000 feet in altitude. Easy enough, right? But it's that second bullet point, prominence, that ruins everyone's weekend. A peak absolutely must have a minimum of 300 feet of prominence to make the list.
Which brings us right to Section 2, the rule of prominence, and this idea of mountain independence.
You see, measuring a mountain isn't just about checking the GPS app on your phone to see how high up you are. You have to account for prominence, which is really just a measure of how much a specific peak sticks out from its immediate surroundings. Think of it as a measure of the mountain's independence from the landscape around it. Is it its own mountain or just a bump on a bigger one?
Think about it like this. If you have a distinct mountain separated by a massive drop, you've got a true peak. But if you have a shorter peak sitting right next to a taller one, well, in Colorado, if that saddle between them doesn't dip down at least 300 feet, oh man, congratulations, you just totally exhausted yourself climbing a completely worthless sub-peak.
All right, Section 3, a history of errors when it comes to measuring mountains.
To really grasp why this is so difficult, we kind of have to look back at the history, because honestly, measuring mountains has always been a mathematical nightmare. The ancient Greeks gave it their absolute best shot, but they totally missed the mark, overestimating Mount Kyllymni by a whopping 56%. Fast forward to 1802, and Great Britain launches the Great Trigonometrical Survey of India. They use these intricate instruments called theodolites to measure horizontal distances and angles, basically creating giant imaginary right triangles in the sky. It was a massive effort, and it actually let them calculate Mount Everest at roughly 29,002 feet tall. But history is full of bad math. They missed one crucial variable,
And that invisible enemy is atmospheric refraction. Those brilliant 1802 surveyors failed to account for this, which, simply put, is just the wildly frustrating way that light bends as it travels through the Earth's atmosphere. This bending light drastically skews visual measurements, so what you see through your lens isn't exactly where the mountain actually is.
This leads us to Section 4, where is the bottom? Finding the starting point. Because here's the thing. Before we can confidently find the top of a mountain, we have to ask a much harder question. Where exactly does a mountain start? And as the researchers perfectly stated, defining the bottom is an absolute can of worms. You pull on one string and the whole concept of planetary elevation just unravels.
Seriously, the whole tallest mountain debate is completely subjective. Let me blow your mind for a second. If you measure from the Earth's core, Ecuador's Chimborazo easily wins, all because the planet has an equatorial bulge. It's physically wider at the middle. But if you decide to measure from the actual base on the ocean floor, Hawaii's Mauna Kea takes the crown. It's actually 2.5 kilometers taller than Everest, it's just that most of it is hiding underwater. And Everest, well, it only wins if we measure from sea level, which is honestly just a totally arbitrary mathematical average of where the ocean should be. Oh, and get this. Just to add a little more chaos to the mix, the most massive mountains on our planet aren't even on the surface. Technically speaking, the world's absolute largest mountains are located deep underground, right at the boundary between the Earth's core and its mantle, hidden beneath miles and miles of solid rock. So, our whole concept of a mountain peak has a pretty strong surface-level bias.
Okay, moving on to Section 5, the LiDAR backpack anomaly. Basically, a backpack glitch.
Let's bring this all back to Christine and how modern technology created her specific headache. Today, we aren't using 1802 theodolites. We use LiDAR. It's a very clean, three-step process. A plane flies over the mountain range, it literally rains down rapid light pulses onto the terrain, and then computers calculate the exact elevation through simple subtraction based on how long that light takes to bounce back. Boom, done. In 2018, using this exact process, science confidently declared that Creststone Peak in Colorado was 4.2 feet higher than its neighbor, East Creststone. East Creststone was instantly tossed aside as a mere sub-peak.
So, the debate seemed totally settled, right? Well, in 2025, researchers taking a closer look at that very same 2018 LiDAR data noticed something weird. An anomaly they officially and hilariously described in scientific terms as Flopzilla.
They uncovered what we're going to call the 4-foot glitch. When they dove into the raw data points on the summit of Creststone Peak, they found one specific measurement that was less than a single foot away from another measurement that was 4 whole feet shorter. Now, unless there's a magical, incredibly sharp, 4-foot natural rock spire perfectly balanced on that summit, which, spoiler alert, there isn't, what exactly did that laser hit to give it that extra height?
And here is the fatal flaw of LiDAR laid bare. On Creststone Peak, the plane's laser pulse almost certainly hit a stationary object left by a hiker, like a backpack. It literally measured a random backpack. Meanwhile, over on East Creststone, the laser happened to completely miss a sharp, immovable 1.4-foot natural boulder sitting right on the true summit. The laser just slipped right into the gap next to the rock. You can't make this stuff up. Which brings us to our heartbreaking conclusion. Section 6, back to the top, and a new 14er emerges.
Because of this ridiculous backpack glitch, researchers actually had to go out and do physical, old-school ground measurements. And those new manual measurements now suggest, with a 99% confidence level, that East Creststone, the one everybody ignored, is the actual peak. The original Creststone Peak, the one everyone has been climbing for years, is technically just the sub-peak. The fallout from this for the hiking community is massive. Just imagine putting in all that brutal work, only to find out a new 14er was basically born right there in plain sight. For Kristen, her previous lungs-burning hike officially didn't count. If she wants to complete her 14er checklist now, she has to go all the way back up that mountain, just to travel those extra 418 feet across the ridge to the real summit.
Measuring our world is clearly this ever-evolving, highly imperfect process. We've gone from the ancient Greeks squinting at the horizon, all the way to high-tech lasers accidentally hitting backpacks from airplanes. It leaves us with a pretty provocative final thought. Is science a cruel mistress when she makes you redo your cardio? And honestly, do you think it's fair that a random hiker's backpack managed to rewrite the topographical map of Colorado for almost a decade? Thanks for joining me on this explainer. And hey, next time you hit the trail, maybe double-check where the true summit actually is.